What's up? It's me again. I got another video for you. And in this one, it's just an upgrade, so to speak, to a previous design that I used. And in the previous design, it was a RAM or like a hard drive storage type scenario. It's fairly compact, only it uses a delay every other tick. For 2 bits, it's 1 tick. Same on for both the write and the read. On the new design, I have 2 actually. This one uses all lamps from read and write. This one uses strictly observers for the write, but I haven't been able to get it to cooperate with strictly observers on the read. So you'd have to deal with a light update on the read portion of it. But the difference between them, this is until everything is written, and this is 16 bits on both of them. And that means they were done. So this one, all of them were read before that one, which is slightly faster, which is good. This is what it would look like if it was all built together. This is the one with the observers. And as you can see, it's all compact. They're all really, 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 really close together. Each bit takes up like a 2x2 area, so to speak, and they can be stacked right next to each other without interfering with each other. And on the end here is the old design, which puts the addresses for the read and the write section fairly close together. These would be the addresses for the read and the write, but the inputs for the input or output, so to speak, for the actual data would be here or here. This is where you would input data. This is where data would come out of, and it could come out on either side. Same with the reads and the writes, come out either or. The reason I did it this way, I've tried to update it, is so that they could all be updated at the same time. So each one of these bits is read at the exact same time on these. And this is pretty cool. And this only works in Java Edition because of the way pistons behave in Java. Whereas when you have, I guess you would call it, they call it quasi-connectivity, you would have the piston would stay down. In Bedrock, it wouldn't do that. But as you can see, it'll work. Let's update this line. Turn these off. And then we'll read from that. And the ones that are off are the ones that were stored. And the old design, so if we went, let's say we'll do boom, boom, space, boom, boom. In this design, it behaves slightly different, but that's not that big of a deal. And then, okay, I'll update it. And then it shows the ones that are on are the ones that were stored. So it just behaves slightly different between the two. But this way is slightly faster. And you can use torches and whatnot, regular torches, to get rid of some of the effect that would be caused by light updates if you took a regular old torch. And I mean, you could use sea lanterns, jack-o'-lanterns, whatever and put it in there to try to eliminate the effect of light updates. But yeah, so this is the way what they look like. This is the old design, and there's a delay each one, which for 16 bits is 8 plus this. You don't necessarily need this particular. This is just to get it down to 1 tick pulse. But this one is 6, 7, 8, and then it's done. And this one would be 4, 5, 6, 7. So, yeah. If you need it detailed, I mean, I'll try to go by it slow so you can see it, but if you need an actual tutorial, I can show you. And I did these two differently as well. It eliminates a little bit of the delay. This one's only 2 versus 3. And the reason this one has to be 3 is because I'm using a torch here to carry the signal up, whereas here I just use a repeater. This one's always on versus always off. And it eliminates a little bit of the delay. But yeah, so that's the design. Hope this helps somebody with their Redstone computers. Have a nice day.